How did Earth end up like this, and not like this? Like Goldilocks' famous bowl of porridge, the home we know and love is located not too close and not too far away from the sun, but at just the right distance for liquid water to exist on its surface. Any closer to the sun and the water would vaporize, any further away and it would freeze. Sure, Earth's location in the sun's so-called habitable zone is one of its main appeals as far as life is concerned, but it can't be the whole story. We know many planets that are located in their stars' so-called habitable zones. In fact, even our neighbour Mars is located at the cold end of the sun's habitable zone. But none of these planets look anything like Earth. Just like you need a recipe to bake the perfect cake, you also need a recipe to build the perfect habitable planet. But what is it? Every recipe needs ingredients. And to find ours, we need to go back a whopping 4.6 billion years. Back to when the solar system was just a blur, or rather a cloud of dust, so rock and ice and gas. Hydrogen, some helium, and smaller amounts of heavier elements such as carbon and iron. If you want to know where these elements came from, check out this video. So these are the basic ingredients we need to make the Earth, the Sun, and the entire solar system. All we need to do now is bring them together to bake an Earth. Under the influence of gravity, the ingredients collapsed to form a spinning disk surrounding a big lump. This lump of matter continued to draw more matter in, becoming more and more massive, heating up, becoming more dense, until finally, at its very center, the temperature and pressure were big enough for hydrogen to fuse into helium. A baby star was born at the center of our solar system, the Sun. Today, the Sun takes up a staggering 99.9% of the material in the original cloud. Only 0.1% that remained further out in the disk started to form first pebbles and then, through collisions, larger bodies. We can see this actually happening in real time even today by looking at other planetary systems. For example, using the ALMA telescope in which ESO is a partner. In this stunning image of HL Tau, you can see a young star and the planet-forming disk. And in this disk, we can see dark lanes, which is where planets are forming. So the material is kind of being gathered up like a snowball by these planets starting to move around their star. It's like we're looking back into the past of our own solar system. And coming back to that, what happened there is that close to the sun, it was very hot. So only molten planets formed near to the sun. Further out, it was cooler, and the rocky planets were able to gather the slow-moving gas around them, forming the gas giants. These gas giants, in particular Jupiter, have had a huge influence on the inner part of the solar system, including Earth. In fact, because it's so big and so massive, Jupiter acts a bit like our personal protector, deflecting asteroids and comets away from us, and keeping the inner planets on stable orbits. But, like every good baker knows, just having and combining the right ingredients isn't enough. You also need time. The Earth didn't look like this when it formed, or for a while after. In fact, for a long time, the Earth probably looked more like this. A barren, molten, hellish world, which is why geologists refer to this period as the Hadean period, after Hades, the lord of the underworld. Over time, heavy elements such as iron and nickel fell to the center of the Earth, and they formed a core where the pressure and density was so high that the inner part solidified. On the surface of the Earth, everything cooled down so that the crust was formed, again a solid layer. So, if you were to peel open the Earth, you would see that it's made up of layers of different material, some of them liquid, some of them solid. A little bit like a yummy layered cake. Even though Earth had a solid crust by this point, it wasn't the most inviting place for life as we know it, because it lacked an atmosphere. Although there was loads of gas swirling around the solar system, Earth's weak gravity was just not strong enough to capture it. But over time, the gas being spewed out by volcanoes all over the Earth's surface built up an atmosphere. And visitors to the Earth, such as comets and asteroids, brought other molecules like carbon dioxide and even water, although Earth was still too hot for it to exist in a liquid form. But there's another vital ingredient that we're missing. And without this ingredient, our protective atmosphere would be stripped right off the Earth by the sun's powerful solar wind of charged particles. I'm talking about Earth's magnetic field. The Earth's magnetic field is formed by all that iron in the core, which acts a little bit like a dynamo. And to see what happens to a planet without a magnetic field, you need to look no further than poor Mars, which used to have a magnetic field, an atmosphere, and maybe even liquid water oceans, but when the magnetic field turned off, it lost all of that and became a dead, barren place. Luckily for us, Earth retained its magnetic field, and with it, the insulating atmosphere, which means that water can exist in a liquid form and make the oceans we know and love. But like baking, making a planet is messy business, and accidents are bound to happen. When the Earth was young, all the way back in the Hadean period, it is thought that another large body, which we call Theia, collided with the Earth, melting it, reforming it, and breaking off a piece to form the Moon. While this sounds horrible and devastating for Earth, it was actually a good thing for us, because the Moon steadies the Earth as it spins on its axis and also stabilizes its climate, allowing life as we know it today to form. There's no one thing that makes the Earth a special place. Instead, it's the unique combination of different ingredients. We are at the perfect distance from the sun. We have a magnetic field. We have a protective atmosphere and liquid water oceans. We have Jupiter as a protector and the Moon as a stabilizer. Altogether, all of these things create the perfect place for life to evolve. But is this the only possible combination? The truth is, we don't know. We found thousands of planets, and we estimate that there are billions of them in our universe. Some of them have promising ingredients. For example, ESO telescopes have found planets in the habitable zones of their stars, and they have also found systems of rocky planets, at least one of which appears to be an ocean world. So far, we have yet to find a second Earth, but who knows? If we keep looking, we may find another recipe for life.